Okay, so good afternoon, everyone. Today is my great honor to be here to attend the IEEE Census 2020. And my name is Hongliang. I'm from the Chinese University of Hong Kong. So today, I'm going to give a representation of our research work, which is the ground target classification from SAR image with the pixel complement for target shape. Okay, so when we are talking about the SAR, actually it is a short term for the synthetic aperture radar, and SAR is a high-resolution airborne and spaceborne remote sensing system for imaging remote targets on terrain. And as the figure 1 shows the geometric observation model for the airborne SAR, the aircraft usually carries a radar sensor flying with the specific direction to generate a synthetic virtual antenna. And in that case, the aircraft just capture the ground target during the flight. And due to this kind of observation model, we could capture the ground target carefully and clearly. And the figure 2 shows the raw SAR image, and the figure 3 is the color map of the raw SAR image. And we could find that the yellow part represents the target body, and the dark part in the color map represents the shadow, which is collected to this kind of area. So the motivation of this research mainly covers the problem formulation. So when we are talking about the SAR target classification, it just utilizes the raw SAR image with the state-of-art method for SAR target classification to classify the raw SAR target image with the real-world target label. So actually, the state-of-art method only utilize the raw SAR image with shadow to finish the whole task. So our question follows the motivation. Why not use SAR image with a complete target profile, which is also means that a target image without a shadow? In that case, we propose our method. The first, step 1, we're going to extract the target contour by the previous paper that we published, and to calculate the central axis to form the direction and azimuth of the target in a raw SAR image. And next, step 2, we're going to find or determine a rectangle area that we are interested in. So in this area, also shown in this figure, a rectangle, that we're going to construct the information in the missing part, which is also the yellow part of this recovered part, to form the completed target profile that we are going to use. To finish this task, we first should locate the 4 pixels in the left, bottom, right, top border. And in that case, we draw a line, a red line, parallel with the central axis. In that case, we could form the final rectangle area that we are going to use, or which means we are interested in. Okay, the step 3, we are going to use a visual model. So this tank is a visual model which is filled in the rectangle area that we are interested in. And by scaling the size of the rectangle, and we could scale the size to the raw SAR image as same as it. And to simulate a SAR image, we're going to do some adding speckle noise. And here we add the speckle noise of 0.1 dB to simulate a SAR image with the visual model. And this is the color map of the simulated SAR image. So the step 4 is what we are willing to achieve. Here is the raw SAR image, and here is our simulated SAR image with the visual model, which is also the complete target profile. And we are going to reconstruct the missing part of this part, and by using the simulated SAR image to generate a new SAR image without shadow, which is also the complete target profile without shadow. And actually, we are not going to change any information in the previous target information in the raw SAR image. To do this, the left here is the image representing raw SAR image, and here is the image represent the simulated SAR image. And we could build a pixel function between each other. And here, this pixel represent the xij, and this pixel represent the yij. And by using the pixel function fxij equals to yij, we could predict the y predict ij in the missing part of the raw SAR image. So step 5, in that case, by using this kind of proposed method, we could combine the raw SAR image and the simulated SAR image with the generated newly SAR image. And we could also find that actually we did not change any information in the raw SAR image in the existed part. We only recover or complete the missing part in the raw SAR image. And this is the ground target reconstruction by the pixel complement in the same area of two images. To validate our proposed method, we're going to conduct the experimental on the MSTR dataset. This dataset is a public mixed target dataset, which is used for the evaluation of the system. And this dataset consists of 10 miniature objects. And the first line is the optical image for each miniature object. And the second line is the raw SAR image of each object. And the third line is the color map. And we could find that each raw SAR image contains the shadows, which affects the target profile severely. And by using our proposed method, we construct all the targets, and we found that the shadow is missing instead of the missing part that we reconstructed. And we are going to use the reconstructed SAR image to finish the next experiment. And here is the raw SAR dataset, and here is the newly generated SAR dataset with the complete target profile. And to validate our proposed method really works or really have a good performance, we just put all the raw SAR dataset and newly generated SAR dataset on the state-of-art methods for target classification separately to classify or to find out which one is better. And we apply all these state-of-art methods with our newly generated SAR image to finish the target classification problem and then compare the final classification accuracy with the same method with the raw SAR image data. The final target classification result with two types of SAR images is shown in figure 8, which represents that our proposed method really works. In every method for target classification, our proposed method of the reconstruct target did a great job in the final classification accuracy with the average promotion of 14.7%, which is a very high evaluation or high promotion for the state-of-art methods in the target classification area. So this is basically what we have done in our paper, and it is also my honor to share with you guys for this work. So thank you very much. Thank you for your listening. Bye-bye.